Hi students, what we're going to look at today is an application of molecular polarity. I've got 4 liquids here in burettes, okay, that we are going to look at. First we'll look at the structure of the molecule, find out if that molecule is polar or not, and then what we're going to do is we're going to see if that will be attracted to a charged rod. So what I can do is I can charge up the rod here, and if the molecule is polar, it should be attracted to the rod. Now, even though the rod is only positive or negatively charged, and polar means it has both positive and negative, what will happen is, if the rod was positively charged, the negative part of the molecule will be attracted to it and will move towards it. Okay? So the 4 liquids I've got here are hexane, ethanol, acetone or propanone, and just water. Very pure water from distilled water. And the ethanol is also known as absolute ethanol. Most ethanol you buy in the shops is a solution with water and often with methanol as well. This ethanol is very, very pure. It's been highly purified, so it's pure ethanol. So these are 4 pure liquids, and we will look at what happens when the charged rod is brought close to them. And we'll do that now. So what I have in this burette here is I have a chemical known as acetone or propanone, an organic chemical. It has a structure that looks like this. That structure, if you create the polarity of it, you can see that it is a polar molecule around the oxygen. Okay? And so what I will do now is I will set this up, and I will have the stream flowing here, and as I bring the charged rod close to the stream, we will see if the stream is affected by that. So I will do that now. So I turn on the stream of propylene, like that, and then I charge up the rod, and as I bring the rod close to that stream, you can see that it moves. Now, it doesn't move a huge amount, but it definitely moves a little bit. So it is attracted to the charged rod. The second liquid I've got here is a liquid known as hexane. It has this structure. Hexane, if you look at that structure, you can see that it is a non-polar molecule. Therefore, it should not be affected by the charged rod. So as I get the stream of hexane flowing here, like that, and I charge up the rod and bring it close, you can clearly see there is 0 attraction. The stream does not move as I bring the rod close to it. The next chemical I've got here is ethanol. Ethanol has this structure. If you look at ethanol and arrange its bond polarities and molecular polarities, you can see it has quite strong polarities, and in fact it has hydrogen bonding around the OH group at one end of the chain. We would expect ethanol, therefore, because it is so polar, to be strongly attracted to the charged rod. So I will start the stream here, and as I charge up the rod and bring the charge close to the ethanol stream, you can clearly see that the attraction is incredibly strong. In fact, it almost does a 90-degree turn due to the charged rod. The final liquid I have here is just plain water. Okay, it's distilled water, so it has no other ions in it. It is a very pure form of water. Water has this structure. As you can see, the bent arrangement around the oxygen and the H bonded to the O gives it hydrogen bonding. In fact, it gives it very strong hydrogen bonding because it has OHs on both sides of the molecule. So we would expect that to be strongly attracted to the charged rod. So let's have a look at that. Now I've coloured this water blue with just some food colouring so that it's easier to see. So So I'll get the stream running here, like that. And if I charge up the rod again, you can see with the blue food colour in the white background, you can see it is quite strongly attracted to the charged rod because it is so polar. So as you can see, if the molecule was a polar molecule, it was not attracted to the charged rod and the stream did not move at all, and that was hexane. The other three molecules were all polar. They were polar to slightly different amounts. The water and the ethanol with hydrogen bonding were very polar. The acetone or propanone was less polar. And so when we looked at the streams and the movement of the streams, the acetone stream moved a little bit, but both the water and the ethanol streams were significantly bent when the rod was brought close to them. In fact, they made a real mess on the table here as the liquid sprayed over to the side. So that's an application of molecular polarity and just showing that we can determine the molecular polarity by looking at the bond polarity and the shape of the molecule. And this proves that those molecules do have that polarity.